So, which method of drying hands is best? Towel or air dry? According to a study on the environmental impact of using disposable paper towels, air blower hand dryers may be better for the environment. The University of Westminster in the UK, a leader in hand drying methods for sanitation, has found that air blowers are less effective than towel drying. Their most recent study found that towel drying spread an average of 1.6 viral plaques over 1 foot from the drying spot, while jet air dryers spread 2,188.7. Another study published by the university reported 35% fewer bacteria on hands that were towel dried. In fact, more disturbing was a study reporting an average increase of 504% in total bacteria on fingertips after drying with automatic electric hand dryers, while drying with paper towel and cloth towel resulted in a 42% decrease and 10% decrease, respectively. The University of Westminster group also found a 255% increase in total bacteria on hands after drying with electric hand dryers, and a 438% increase in numbers of intestinal, fecal bacteria, and skin-associated Staphylococcus spp bacteria. It's hard to believe that using an electric hand dryer would increase the number of bacteria on washed hands to the extent found in these last two studies. But the results indicate that electric hand dryers are in fact less effective in removing bacteria from the hands than paper towel drying. And there's more. Several studies attributed higher bacterial numbers found on hands after drying from using warm air and jet air dryers to the release of bacteria from skin folds and crevices due to rubbing hands together during drying. To make matters worse, using electric hand dryers spreads bacteria from hands to surfaces around the blower by aerosolizing bacteria. Despite these findings, FDA Food Code still states that using warm air dryers is an acceptable method of hand drying for food service workers. To see for ourselves, we conducted 2 experiments to determine how air hand dryers can contribute to the transfer of bacteria. Experiment 6.1 tested hand dryers installed in public locations, and Experiment 6.2 tested how far commercial hand dryers can spread bacteria. Overall, these experiments demonstrated that microorganisms contaminate both the air inlet and operating controls of public hand dryers, and that commercial hand dryers aerosolize and spread microorganisms into the area immediately surrounding the dryer. Experiment 6.1 Bacteria on public hand dryers. Materials and methods. We sampled hand dryers in these public places: on the Clemson University campus, 25 dryers; at gas stations, 14; and in grocery stores, 21, for a total of 60 electric hand dryers. We took air samples by placing an open Petri dish filled with plate count agar 6 inches from the outlet nozzle of each dryer. We also took swabs of dryer surfaces, such as the activation push button and inlet air vents. Air velocity, air temperature, and relative humidity were recorded for each dryer using a handheld hygrothermometer. Placement of the air sample Petri dishes at a distance of 6 inches was based on information from a hand dryer manufacturer that said most people place their hands approximately 6 inches away from the dryer air exhaust. The dryer was activated, and the nutrient agar was left under the air exhaust for 30 seconds, 1 cycle. A second plate was exposed for another cycle immediately following the first. Science stuff ahead. Immediately after sampling, the open-air plates, Diffco plate count agar, Becton Dickinson, were covered, placed in clean plastic bags, and transported to the laboratory. There, they were incubated at 37 degrees Celsius for 48 hours before total bacteria colony-forming units, CFUs, were counted and recorded. The dryer activation button and inlet vent of each hand dryer were also swabbed for microorganisms with a 5.5 centimeters x 5.5 centimeters sterile gauze, previously wetted with 20 milliliters of sterile 0.1% peptone water.